Hello and welcome to this first ever online-only CocoaHeadsNL meetup. My name is Marco Miltenburg and at CocoaHeadsNL I am responsible for all the video recordings and live streams. For the people that are new to CocoaHeadsNL, we are a monthly meetup group for Apple developers. We are part of the International CocoaHeads and talk about anything Apple related. As you all probably already heard, our scheduled meetup had to be cancelled due to the coronavirus. The Dutch government has banned all gatherings of large groups of people until at least April 6th. Because we already have a lot of experience in streaming our regular meetup, we took the challenge to turn this meetup in a pure online-only meetup. That means that our regular speaker for tonight, Antoine van der Lee, is not in the same room or even in the same city as I currently am. He will actually be presenting from his living room, as he is also working from home due to the coronavirus. Unfortunately, there will only be one talk during this live stream. We plan to have a second talk by John Reed, a name most of you will probably know. John was in the Netherlands for some conferences and workshops, but had to decide to leave earlier because of the very limited number of flights that are still available to the USA. He felt it was safer to leave early before he was not allowed to go back anymore. John has agreed to speak at the future CocoaHeadsNL meetup though, so he will be back with us. So let's get started. First of all, we'd like to thank our regular sponsors. They make it possible for us to host our meetups and to record and stream them as well. We also like to point you to our apparel shop at CocoaHeads.nl/shop. We can't see you now, but for sure you look better with some CocoaHeads swag. Our next meetup is scheduled to be on April 22nd at bol.com in Utrecht, but we have not yet published that event yet, as it is very uncertain that it will go ahead. We hope to inform you about it anytime soon. So today we just have one speaker, Antoine van der Leij. I will leave it up to him to introduce himself. He will be talking about asynchronous programming with operations in Swift. Enjoy!
All right. Hello, everyone. It's kind of strange. I'm sitting here all alone in my living room. All kinds of things can go wrong. I certainly need to do shout outs to my friends who are also listening, the TV-gids. I don't know, you know, like normally when you speak, you get like feedback from the audience. And now I seriously have no feedback. The only thing I see is my slide, but I'm pretty sure you all follow this, and I can do whatever is needed to teach you everything about asynchronous programming with operations in Swift. I hope you're all fine. The coronavirus is kind of taking over the world, but there's never enough reason to go and learn more about Swift. So let's make the best out of it and see whether we can do this remotely. So I want to start with a short introduction. I'm going to talk about asynchronous programming with operations in Swift, which we do quite a lot at WeTransfer. And this is a short video I want to show you.
You're a developer and you've just spent 2 weeks or maybe a little bit longer writing this amazing app. And what is your dream? Your dream is to get it in front of every iPhone user. And hopefully they love it and buy it, right? That's not possible today. Most developers don't have those kinds of resources. Even the big developers would have a hard time getting their app in front of every iPhone user. Well, we're going to solve that problem for every developer, big to small. And the way we're going to do it is what we call the App Store.
I hope this was a bit doable to follow. The sound came from my MacBook. But yeah, normally I would ask you, like, what is the year of this presentation? I'll give you a sec to think about it, and maybe you know. But this was the year of the iPhone 3G. This is quite a while ago. In fact, it's kind of funny if you think that this was Xcode at that time. Can you imagine building an app with this UI? It's pretty basic, and it's far from what we have today, luckily enough. This was me in the same year, and we're talking about 2008. Yeah, that's like 12 years ago. But that year, we already could work with operations in Swift. This is the documentation from Apple. And as you can see, iOS 2 introduced the first operation class. And if you think about this class for over the years, it wasn't always visible to everyone, and it wasn't used by everyone. And I want to kind of convince you. And it all started for me with this WWDC session from 2015, which I can highly recommend. it goes over NS operations in an advanced usage, and they use the WWDC application, because the fact is that the whole WWDC app is built with operations, and it might go a bit too far in the sense that they also use it for UI stuff and like validating whether a user is logged in before doing a certain operation. But it does show the power of operations and how you can use it. This is the collect by WeTransfer app, which I'm working on a day-to-day basis. And this is heavily built on operations. I remember us deciding 3 years ago what to use as our main structure, and we slowly started to build more and more operations. And in fact, right now, we have 48 operations. And I have to say, I created 2 again today, so it's actually already more. But yeah, it's paying off for us, and for us, it really works. And we basically see an operation as a solution for writing asynchronous code. Yeah, that's responsible for a single part, but as well really testable. And I want to show you a bit more about that. And hopefully I can convince you that this is the next cool, well, kind of old thing. But why? Why operations? Well, let me show you a few reasons. Operations really are suitable for writing a single responsible code. And with that, I mean that your class is only responsible for a single thing. For example, we have a content import operation, which only does the importing of the content. And we have a content upload operation, which is only doing the upload part. And the great thing is, because you have the isolated code, you can also easily write tests. Or at least it makes it a bit more isolated, so you don't have a really big test class as well. Then there is the great benefit of chaining operations together. So here we have an import operation and an upload operation, and eventually we set a dependency between both. So what we say here is the upload operation can only start after the import operation is finished. Another benefit is that you can reuse operations. So we have the upload content operation, as we introduced before, and we can use it after importing content, but as well after copying content. This makes it possible to write code once and reuse it in multiple places and easily chain it all together. This can be a huge benefit, especially in a bigger code base. Also a great benefit, as I showed before, it's part of Foundation. It's developed by Apple, and it's an API which is available since iOS 2, which makes it quite mature. It's been tested, it's been used quite a lot. Yeah, you can build on that. But 3 years ago when we decided for this, I remember myself also asking my colleagues, like, why not importing RX Swift? Or maybe today, if you make the decision today, why wouldn't you import Combine instead? These 2 frameworks could be a great solution for asynchronous programming as well, right? So I can imagine you have this thought, like, why should I go for operations? This is one of the reasons I would say go for operations over a framework like Combine. It can be quite hard to debug. It's obviously not always the case, but it's definitely a reason to think it through and whether you should really use Combine as your core foundation in the app. With RX Swift, you're introducing an external dependency. It's also third party, so it's probably likely that they need to do some updates. RX Swift is well maintained, so it's a really good framework to use. However, it's still like, it's not part of Foundation, right? So that's the main point I want to make here. And then there is the case of Combine, where your deployment target needs to be 13 and up. And this is for now something you have to think about. In a year or 2, this decision might be different. But for now, at least, if you want to use operations, you can use and support all the iOS versions available today. Of course, you could work with the availability API, but then you still have to maintain more code than you would do with operations. And even if you do, these kind of generic codes aren't as readable for everyone. We will write some generic code later on as well with operations, but I just wanted to show that it can be quite complicated. So we now know why you should use operations, and you know that Collect is heavily built on operations. Now I'm going to do a live coding session. So we're in a live stream, in a live environment with all things that go wrong, and we're also going to do live coding. So bear with me. Either way, I'm going to go over the basics, and I will also show you how we use operations in Collect. So I created this playground. I think I will try to put it online as well. Previously, when I did this presentation, it was highly requested as well. So let's see if we can do that. So yeah, let's start with the basics. Kind of be better if I keep it in the middle. Yeah, okay. Right. So we start with the operation queue, and the operation queue is a higher level implementation of the dispatch queue. What it basically allows is to add operations to it, and it gives you extra controls like cancellation and setting a maximum of concurrent operations, which basically means that at a certain moment, at maximum, there can only be run a certain amount of operations at the same time. The operation queue works with operations, formerly known as NS operations, and they basically are a high-level implementation of the dispatch block. And they are great for running long-running tasks, but the real power is in the subclassing of operations. This is the very basic implementation. Here we have a block operation, which basically executes a simple closure, and you can set a completion block to any operation you have. So I can run this code, and we can see that it first executed, and then it completed the operation, just like we printed out. This is quite basic, so I think this is still followable. Then there is also a shorter version of a block operation, as you can see here. And if we can run that, you can see that it's basically executing as well. This, however, doesn't allow you to set a completion block. But it's just good to know that these APIs exist. Then there is the order of execution. And the operation queue basically runs operations in the order that they are added. So here we add operations, first the background operation, and then the user triggered operation. And notice that in this example, we use the wait until finished as well, which basically says block this thread on which we're calling this method and wait till both operations are finished. So if we run this, we see that the background operation is finished, and after that, the user triggered operation as well. However, we have a user triggered operation, and it's in general a best practice to make sure that those user triggered operations are executed first, and background operations can be delayed until it's actually, well, a bit more quiet in the system resources to execute the operation. So what we can do is we can set the priority of an operation, and we could set it to very high, because hey, we have a user triggered operation and I want to make sure that it's executed first. So before we had the background operation being executed first and then the user triggered operation. And if I run it now again, we can see that the user triggered operation is executed first, even though the background operation was added at first. This is a common way to do it. However, there's also another API which I wanted to show you, which is the quality of service. By default, this is set to background, if I'm right. And for now, we could say like, hey, this is user triggered. in other words, user initiated. So we can set it to that quality of service, and that makes sure that this operation is executed as soon as possible. As you can see, we first have the user triggered operation and then the background operation. This is great for doing like UI stuff where you want to have a response as soon as possible. And it's really easy to handle this queuing mechanism just by setting the quality of service or by setting the priority. I have like a certain sheet of feedback, and I heard that the font size could be a bit bigger. So let's do that. Hopefully this makes it a bit easier for you to follow. So yeah, let's continue. An operation can be reused, but the same instance of an operation can only be executed once. And I can demonstrate that. Here we have the perform operation. This is all working fine. But say we use this same instance of the operation and we edit again, we directly get a beautiful crash, which is not telling us a lot, but I'm pretty sure it's about adding the same instance again. You can reuse the same type of operation, but you have to create a new instance and then it all works. And then we come at the part of creating a custom operation. And this is where operations really shine, if you ask me. I created an example of the content import operation, which we saw before in the slides. It basically takes an item provider, and we have to still write the logic for doing the actual importation. I did the setup, I set a completion block, and I added to the queue. If we run this now, we will basically only get the import completed, but let's do some implementation logic here. For now, this is only a synchronous operation, so that's the default. And to implement the logic, we need to override the main method. The main method is basically executed upon the start of the operation, basically as soon as the queue triggers the operation when it's ready to be executed. So what we can do here is print importing content. Of course, this is not actually importing content, but I don't want to spend time on writing that logic. Just imagine that this is the whole logic for importing content. And if we run this piece of code now, we will see that we have the importing content, and afterwards we have the importing completed. This is the bare basic of creating a custom operation. But yeah, we will soon get into the more advanced versions. But first, I want to show you the different states of an operation. Because an operation can be an executing state, as well as in a finished state or a canceled state. And to show you that, I've created an observer, which basically observes every state change on an operation and prints that out to the console. So I can run this code. And whenever you see a dash, that's basically a state change. So we first have the executing, which is set to true. Then we have the perform operation, which comes from the main method. Then we have the operation completed, which is coming from the completion block. And after that, the executing is set to false and finished is set to true. This is great. So we now know how the operation is changing state. But then it's interesting to see what is happening if we cancel an operation before it's getting added to the queue. So we add a cancel and we run the code again. We can see that canceled state is set to true, and the operation is basically directly getting completed as soon as it's added to the queue. This is great. I mean, the operation was canceled, and due to multi-threading or whatsoever, it could be that it's still being added to the queue, but we don't want it to actually execute. And the operation class takes care of that and makes sure that our main method is not getting called. However, in multi-threaded environments, it could also be that the operation is getting canceled at the same time from a different thread. In this case, it's getting called directly after we added it. And if we run it now, we can see that canceled is set to true, but after that, still executing is set to true. And the whole operation is performing. And this is not what you want. So we can prevent that by writing a little piece of code in our main method where we say like that we want to make sure that the operation is not canceled. Otherwise, return immediately and don't perform the operation. So if we run this piece of code now again, we can see that the perform operation is actually not triggered. The rest of the states are still being managed, but that's not really a big of a problem. For now, this is perfect in our asynchronous operation. Then I wanted to show you a bit of the dependencies, so adding dependencies between operations. And in this example, we have an import operation and the upload operation, just like we had before in the slides. And we set a completion block on each. So we have an import operation completion where we say importing completed, and the same for upload completed. We add the operations, and I did this on purpose, where I set the upload operation before the import operation, just to show you like the order of executing. So we first have the uploading content started, and then we have the importing content started. However, we want to only upload once the import of the operation content is done. So what we can do is we say upload operation dot add dependency, and we say import operation. And even though the upload operation is added at first in the array, it will not execute earlier than that the import operation is finished. You can see it from the log. Importing content started, importing is completed. After that, uploading content started and uploading completed. This is great, especially in an example where we have an upload operation that needs to be executed after importing. Just simply set a dependency and you're basically all set up. Imagine you writing an upload content operation and it's a custom synchronous operation. And you did what I just described. You have the isCancelled property set. However, it doesn't make any sense to do the upload if the importing was canceled earlier before. So we can make any operation that's dependent on another operation a bit more advanced by firstly checking whether the dependencies isn't any containing any operation that was canceled before. So we say dependencies contains where operation that is canceled. So what we basically say, whenever the dependencies contain an operation that is canceled, we want to return. So that's what we do with exclamation mark here. And this makes sure that our operation is never getting executed whenever its dependencies were canceled before. This is great. Once again, this makes sure that we don't do any unnecessary work. Now we enter the fun part. We're going to create an asynchronous operation. And I'm going to do this in a manner of how you would probably do it yourself. And want to start with executing this code to see what we have. So we print out the state changes once again, which you can see with the dash. And we also print out the operation completed whenever the operation is done. And we created a certain delay in our main method where we perform the operation a bit later. And this is basically code to mimic sort of like a long-running task, which could be like executing a certain endpoint for your API. It's clear that we need an asynchronous operation here. Because once again, if you look at this, you will see that the perform operation will be printed out a bit later. So, okay, you want to make this an asynchronous operation, and you dive into the documentation, where we can see an is asynchronous property. That's great, right? Like, let's override that, and we will have our asynchronous operation, isn't it? At least that's what I thought at the time. So I return true. Here we go. And I execute the code. Nothing really changed. And the reason for that is that we have to manage the states ourselves. And that kind of makes sense because we need to have a way to tell the queue like, hey, our asynchronous work is done. So we will need a way to set like, hey, this operation is finished. To do that, we first need to take over the state management. And to do that, we need to override the start method. And there we basically start by managing the same kind of state changes. To have a bit more detail on that. So let's execute our code again and see where we are. This is pretty sad. We don't get any prints, and that's because we need to call main ourselves now because we took over the start method. And this would already improve the code because now we get the print statements of the perform operation. However, we still observe the state changes, and we don't really see anything happening there. And the reason for that is that we are handling with key VO, a key value observation. And that's basically also how the queue works. So at this point, the operation queue is not getting any noticings that the operation is either started or finished queue. So what we need to do is we'll change value for key, where we say that is executing will be changed. And I realized that this is the get. I normally would have had an audience to help me here, but I'm all alone. Either way, so far so good. And now we can run it again and see what it does. All right, awesome. So this is great because now we have the executing property which is set to true. But we only need to create a finish method where we can say like, hey, the perform operation has been done. We're also done executing. So we can say self.finish and create a new method. Finish, where we say is executing is false. And indeed is finished. Oh, I'm doing it wrong. Like that. Is finished is true. And this requires us to create another property for is finished in this case. But we can basically copy over this piece of code and call this is finished. Copy that and paste it a few times here as well. And here as well. The is finished property works exactly the same as is executing, and we need to handle this. And this should be all to finish off our finish method. So we can execute it once again. This is great, but we don't see the finish property still. We can run it again, because the fun fact is that it sometimes does print out, and sometimes it doesn't. Either way, one thing what you have to do, because we're working with key VO, we need to first let it know that it's set to false. So it's kind of like odd, but this is actually needed to make sure that this line will actually do a key VO change. Because if we run it now again, we can see that it's doing exactly what we want. It's first changing finish to false, then it's executing. It does the perform operation, then executing is set to false, and the operation is completed. And finished is true. And it's good to realize that in the completion block, it's not always true that the finished state is also set. So if you do any comparison in the completion block to make sure that it's actually finished, that wouldn't work. But honestly, completion block is called when the operation is done, so you don't really have to check that either way. This is basically everything we need for a base class, which gives us an asynchronous operation. And the great thing is that you can now start using this for all kinds of tasks. So let's go to the next page, where we have an example of an asynchronous operation. And this is showing a bit more what it can be, because honestly, when you do this, you can basically copy over the asynchronous operation I've written here. You don't have to do that yourself. The code you're actually going to write is the example code you see here, where you create a new class, which is using the asynchronous operation as its base class. And in the main method, you're doing your asynchronous job, which in this case is an upload task, as we have a file upload operation. You can handle the response, and finally you call finish to let them know that the operation is finished. And something new, which you didn't see before, is that we override the cancel method here as well, where we make sure to cancel the upload task. Because if your operation is canceled, you don't have to continue doing the upload. This is great, but we thought we can do better. And reason is that we basically almost always work with results-driven operations. So we started creating an asynchronous result operation. And this is where our generics will be introduced. We first create a success generic and a failure generic. And then we make a new property, which is privately settable only, but readable from the outside, where results. It's an optional because it could be that in the beginning it's not yet set. And then we get warning that failure needs to conform to the error type. So we can do that with the where statement, where we say where failure does error. Awesome. All right. So now we have a result. But we want to make sure that the result is actually getting set. And if we do just the bare finish method, we obviously wouldn't have a result. So what we can do, we can help our future self whenever we implement an operation. So we can say, fatal error, this is a programming mistake. You should use finish with to ensure a result. Of course, we need to create that method. So let's do that. Finish with result, result success, failure. And then we can say self.result is result. And we call super.finish. Note that you have to call super, because if we call self.finish, we would still end up in the fatal error, which wouldn't bring us a lot more. This is great, but we have another scenario, which is cancellation. So we need to do the same for cancel. You can override the cancel method and say fatal error. You should use cancel with to ensure a result. And then we need to make that method as well, cancel with. And note that I'm only using error here, because we think at WeTransfer that this is the case where like cancellation is kind of a failure setting of the operation. In the end, the operation isn't finished. So it's kind of like, you could see it as a failure. That's at least how we handle it. It does require you to create an error type with a canceled case, but it's at least a lot nicer. Yeah, I think it's better readable in that sense. So what we can now do is set the result with that error, and it all conforms to the same error type, which is great. And then once again, we need to call super.cancel. This is everything we need for an asynchronous result operation. We can make it a bit more nicer as well, where we create an onResult callback, which basically says that whenever a result is set, you want to get a callback. So success and failure, and it returns void. And then we can say did set guard let result is result, and then we say on result. This is great because now you can actually make use of the, you can basically use this as your new completion block. So whenever you have an asynchronous result operation, you can set the onResult property and print out the result of the operation. And I already created an example to show you exactly what I mean with that. And in this case, we created an unfurl URL operation, which takes a short URL and returns the full URL. So we created an onResult callback as well, where we print out the operation finished with. And you could also already see it, but let's just execute it once again. And then you will see that it doesn't work. Maybe because the internet connection. No, I should have an internet connection because otherwise you can't hear me. Either way, it's great that I had the previous print in printing out. So yeah, you could say that it normally works. Live demo. I'll have another example later on. Maybe that does the same, but you get the idea. This is basically the outcome of the unfurl operation. I want to dive into an even more advanced implementation of operations, because we realized that we often have like dependency operations. So as I showed before, we have the content import operation and we have the content uploaded operation, and they are basically always chained together. So they also expect a certain input and given a certain output. And that's why we created a chained asynchronous result operation. And it builds forward on the asynchronous operation we had before. So we can say input and a failure type, where failure that conforms to error. And here we can say, this should be output, because it's the output of the asynchronous result operation, of course, it's the result. And here we can say we want an input, an output type, and a failure type. This way we created a generic operation which takes a certain type as input, gives a certain type as output, and has a certain error type set. And now we can create a private settable private set for input, which is an optional, because the thing is that the chain has to start somewhere. And it could be that the first operation in the chain doesn't require any input. So let's make an initializer for this. Input. This allows us to initialize without an input as well. We could say that it's default to nil, and then self.input is input, and then super.init. All right, this is great. However, we need to make sure that upon executing, we actually have an input. And as this is a chained asynchronous result operation, it could be that this is also the second operation in the chain, and we want to have the input based on the output of the previous operation. So to do that, we can override the start method, and we can say if input is still nil, which means that we didn't initialize it with an input, we could say update input from the dependencies. And afterwards, we say super.start to let it run just as normal. We don't need self here. I always like to keep that clean. And we can copy the method name to create a private thing. Update input from dependencies. So here we will run into a certain problem, because we want to go over our dependencies, cast them to an asynchronous result operation, well, basically a chained asynchronous result operation, and then we want to get the output. And I can show you what I mean with that, because if I do this and I say compact map to only return the operations that actually conform to it, you can say chained asynchronous result operation. This will not work because it requires you to give the types as well. So we can say chained asynchronous result operation, and then first dot result and get as input. And then self.input is. Yeah, that's true because this is a try, and now I can say try. You know, I start to realize that this is actually working. It's kind of funny because I thought before that it wouldn't. And that's why I also created this chained operation output providing. So maybe this presentation is in the end a sort of a rubber ducking operation or presentation. But either way, I'll show you what I did before. What I did before is I created a protocol with a certain output of type any, which is only a get. And then I had an extension for async result operation to conform to that output providing protocol, say for output any, and return the try result dot get. And then what we could have done, let's copy this for the sake of the future, and then we could say operation as output providing that first. Yeah, of course. Output as input. This was the way I did it before, and then we don't have to try, obviously, because that's now replaced and moved into the output. And this should be all to basically update the input from the dependencies. And note that I said before that the first operation could have a nil input, and then this would still be executed. But that's kind of fine because that first operation wouldn't have any dependencies. So it would stay, the input would stay nil. This is great. This is the only thing needed to create a chained asynchronous result operation. And this is also where we can show the example. And in this example, I have the unfurl URL chained operation again, which takes a short URL. It unfurls it, which basically creates the long URL. And then we have a fetch title chained operation, which fetches the title of the link and prints that out as well in the onResult calling. I'm pretty sure this will not work now as well. Maybe it does. Oh, it does. Okay, that's great. That proves that my code is working actually. Either way, let's go into the unfurl chained operation first. And as you can see, we created a chained asynchronous result operation that takes as input a short URL, which in this case is just a type alias of URL. The output is set to a long URL, which in this case is a type alias for URL as well. And we have our error type. In our main method, we created basically the logic to unfurl the URL operation. Sorry for that. Where the code completion is not really helping us out here, but you can see that we take the long URL from the response. And whenever the short URL isn't returning a long URL, then we finish nicely with a typed error. And eventually we'll finish with the long URL. There's also a cancellation, which does the data task.cancel. And here you can see an example of the cancel method where we give the canceled case as an error type. Then we have the fetch title chained operation. And here we say that the input is a URL and the output is a string, where this is basically a long URL, but in theory, you could also use a short URL. So that's why we don't use a type alias. And we have a string as an output, which will be the title of the page. I can go over this logic. I'm pretty sure I will set the code online for you to dive in. But it's kind of logic to simply get the title tag and get the value out of it. And then once again, you get this nice code where you have the unfurl operation and the fetch title chained operation, which are dependent on each other through the dependency method. And that's basically the implementation we have and we use heavily in the collect app of WeTransfer. And I showed before the examples of importing content and uploading content. This is also an example where we have a short URL and a long URL. And that is actually an example of a whole chain we have in Collect, where we first get a short URL of a transfer, we convert it to a long URL, we get the data, and we finally import it. It's really nice. It's working out for us, and hopefully this showed a bit to you as well what it can do, and hopefully it's also the next cool thing. I surely want to tie back to bring you back to the principles I said before, because in our opinion, the reason to go for operations, it's allowing you to write code which is responsible for a single thing, like importing content only or only uploading the content. That allows you to write tests in a more easy manner. You're really focused on a certain thing. Your test classes will probably be a bit simpler to maintain to do that as well. Last but not least, this is all part of Foundation. You can use it directly, support older iOS versions, and it might also bring a shorter learning curve for your colleagues due to that. A short shout out to Swift for Good. Swift for Good is a book which you can buy, and all money will go to charity. It's a great book with 20 different authors from the community that all wrote their own chapter. I did my chapter as well, and not as a coincidence, it's all about operations. I'll explain there in a lot more detail how you can use operations and a bit more background story. Last but not least, I'm sharing every week new content on my personal blog, Swiftly. I also got a newsletter with curated content, which I send out every Tuesday. Check it out. It's probably really interesting for you to learn new things about Swift. This normally works great when I do a talk and I have an audience. You can pick your phone, scan it, and that will bring you to my Twitter if you want to follow me. I have no idea whether this is long enough, so I count to 5 for myself, grab a bit of water, and then I'm pretty sure you have had your chance. And then that's it. Thank you very much. I'm not hearing any applause. I hope you're still with me. It could be that I'm speaking towards nobody for over 30 minutes now. But yeah, I think it worked out, hopefully. All right, I think we're going to have some questions now, and I got some assistance with people picking up the questions for me. So I'm waiting for input now. I should probably check Slack for that. Yeah, there we go. All right. We got a big list. All right, cool. Okay, so this is certainly a whole new thing to learn. I need to read a question and come up with an answer. Daniel Steinberg. Yeah. All right, so if I wouldn't have to support pre-iOS 13, would I instead go for Combine, or would I still prefer operations? This is an interesting question, because I think 3 years ago I did a talk and I was a big supporter of functional reactive programming. And at WeTransfer, I kind of lost my belief. And now Combine is back. It's an Apple framework, and that makes it kind of like easier to jump in that boat, because it's no longer an external dependency. So, I mean, that would be a reason to not do it in that sense. Combine allows you to write pretty nice code. The thing I dislike from Combine, at least right now, it's a bit harder to write your own custom publishers. So say, for example, you have the content import operation and you want to make that a custom publisher. That is, at least for me right now, not as easy to do. You could obviously write an extension on publishers. That could maybe then be the way forward. Honestly, right now, today, if I would support iOS 13 and up, I would still go for operations, but that's also my personal preference because I'm really into operations right now, and we kind of benefit from it every day that we transfer, and it's a bit easier to understand for us. And I think the code is a bit simpler as well in that sense, and we don't have the learning curve of functional reactive programming. So I would say it depends on your situation, and if it's a new project, you start freshly, and you don't know you don't know much about operations yet as well. Then you have a learning curve for both, and then it could be just as good a choice to go for Combine, I think. I hope this answers your question, Daniel. Otherwise, feel free to ask for more details later on. Next question. I have quite a lot of questions. I'm pretty sure I can't go over all of them. So let's pick a few. Yeah. So Lambert asked me, why do you think operations never got very popular and people prefer to use things like RX Swift? Yeah, that's a good question. I think RX Swift is in general just really a cool kind of framework. It's driven by open source community, so maybe it got a bit more shout outs. It's also true that it's available in all different languages, so RX Java and those kind of frameworks, which helps it a bit as well. And in terms of operations, I mean, it's not developed by the open source community, so there's not a lot of shout out around it as well. But still, yeah, I mean, I hope this presentation helps to make the group behind operations a bit bigger. But it's really hard for me to say like why it never got really popular. Yeah, curious about your opinion on that as well. Yeah, so there's a few questions about will the project be shared on GitHub. I'll make sure to do that. Hopefully, I can do that tomorrow. And then Bruno asked me, what is the most non-obvious part of WeTransfer they use operations for? So let me give me a cheat where I can go back to the slide with all the operations on it. So there's a few here, and let me see. Yeah, I mean, they all make kind of sense to me, at least, because I know them. Yeah, I don't know. I think all the operations are built with a certain ID behind it, right? So, yeah, it's actually doing a certain problem. It's doing syncing to the backend and file operations, importing operations like video assets, and yeah, I don't know. Yeah, for me they're all really obvious, but if I come up to mind with a different operation, I'll let you know. Yeah, sample code again. Yeah, same question as well. Yeah, a lot of the same questions, kind of asking like whether Combine will replace operations. Yeah, Lambert asked an interesting question. Is there a convenient way to deal with retries of network errors? My answer to that would be to solve this in your networking framework and not per se in your operations. And in your networking framework, you could basically catch a response before it's going back to your implementation level and wait with returning the result before you retry it at least one time more. If you want to see an example of that, we're using Alamofire for that. Alamofire has a retryer, which works really nice for that, and it allows you to easily retry a few times before returning the response. I know that frameworks like Combine are a lot easier with it. You simply have an operator for that. However, yeah, I mean, it's at least the answer in terms of operations in this case. So Axel comes with an interesting question. I have not dived into Combine too much, but is it possible to create a task/operation and distribute hundreds of them along multiple processors? So what you will run into is the maximum concurrent operation count I shortly showed that in the first page of the playground, because the system has a certain resources available for your operations to execute. And by default, it basically takes as much as it can based on the current available system resources. But it could be, for example, if your phone is low on battery, it will only allow your app to execute 2 at the same time. So even if you distribute hundreds of them, yeah, they will be maxed out, I'm pretty sure. Is the completion always called, is what Marius asks. Also when an operation is canceled. As far as I know, it is, because an operation is still completing when it's canceled. It's just not succeeded. But the operation API itself doesn't know whether it's succeeded or not. It knows that it's canceled or not. So yeah, the completion callback is always called. Yeah. Then a question from Remy: Can they coexist with normal GCD asynchronous calls? If you mean that you can use GCD inside operations, then yes, that's possible. If you want to like depend a GCD dispatch block on an operation, I think that's a bit harder. But yeah, don't forget that operation queue is basically a higher level implementation based on top of GCD. So yeah, I'm not sure whether this is actually a scenario you need to support. But either way, yeah, I think they should work together if you use them inside an operation. Yeah, Majid also asked whether the playground will be available. I'll share that out on my Twitter as well as in my newsletter upcoming Tuesday. So if you don't want to miss it, you can subscribe there. And I don't get any new questions, so this is it. Yeah, 90 people watched it, so that's good to know. I wasn't alone all the time. It did feel a bit like that. I mean, I didn't get any response, but yeah, I think thanks a lot, everyone. If you have any questions and you really want to have an answer, feel free to reach out to me on Twitter or in the CocoaHead Slack. I'm available there as well. I'm happy to chat with you and see if I can answer any of your questions. So yeah, thanks for that. Waiting for the queue then from our CocoaHeads. Okay, top. Ja. Oké, maar is er dan heel veel van mijn presentatie niet gezien? Of, Oké. Ja. Nee, ja. Oh, wat cool. Ik zie foto's op Twitter van hoe het eruit zag. Nee, nou ja, goed, dat is dan maar zo. Misschien dat je... Oh, everyone can still hear me?